Welcome to our video. We are trying to figure out how to measure stuff. Okay, why are we doing this?
We're doing
we can make a 2D cone all the way down the hallway. What is the 2D cone?
Basically, the cone represents the sun to the earth, and the diameters of each length is the math part of it. So you're starting at 100 centimeter increments, and then with the 100 centimeter increments, you're going smaller. Your diameter will get much smaller because you're going from 32.7 centimeters all the way down to 0.3 of centimeters.
So is this the equal distance is this the ratio of the equal distance between the sun and the earth?
Yes, this is a scale drawing of it, and it is the length of the hallway, which is 35.27 centimeters. And so basically, we kept going back through and seeing how small we actually had to make the diameters in order to make it fit the length of the hallway.
Okay.
So
how do we do the math for that? Brianna, your turn.
You understand that?
Yeah, I understand it.
Here, I'll write it.
Okay, so the distance between the two is
Film her
the distance between the sun and the earth is 150 million kilometers.
Okay, why is Cheyenne doing that?
Bigger minus smaller, 10 minus 4, getting 6, but keep the sign of the line.
What's the math? What's that math?
That's finding the increments.
Yes. Why those numbers?
Especially when we get a lot of
Because we have to find certain parts of the cone to
Measure slope. Okay, so we have the cone.
So now we are doing slope, and why they are neither parallel nor perpendicular. So what are they?
So you're starting on a graph.
What symbol do we use for nothing?
0. Okay.
Starting at 0, 0.
We're trying to solve for x, and you said that x
And you go to 0, 32.7, because 32.7
you have to find out what x
is the
scale.
diameter of the sun, and it's the scale it's going to figure out. Basically, your midpoint will be the same across the board.
Add them.
Negative
Are these things?
0,
Yeah. So let's get them together. What are we
16.35.
gonna do?
That is half of this portion, even though you are going
So when I
at a
move,
slope.
it's negative 12.
Um,
What happens then?
Basically, it will have to be the same across the board, even though you're at 0.3 centimeters. And how we got the slope is
What's left on this side?
you take 16.35, the middle number,
So once
and you're going to divide that
things that I
by
like,
3,527.7.
you just divide. Usually.
And that's how you get your slope of
More times than not, you're gonna
0.00459.
That's when you divide by
Now the reason that they're not perpendicular is because this is a negative, but it's not the negative reciprocal.
See how
It's
that
just
works?
the negative of the same number.
Oh, okay. Increments.
I'm explaining how to get the increments. So any given point between the sun and the earth. So we'll take the two equations, which are
You get 1.
these.
Very good. So I can move.
Okay, so you'll plug in whatever the distance is, and
By what? That's 100.
3.
distance in
Okay, 18.
The distance in centimeters.
centimeters.
Oh, okay, so every 100 centimeters there is going to be a different point.
Yeah.
Alright.
Okay, so you take
What do you get?
this and you multiply them together, and you get
Oh, okay. Okay.
Yeah, you're cooking with that.
4.459,
Very interesting. That you picked up on. Just practice it.
and then you take this and multiply it out,
Done.
and
Okay.
you add 37, and you get 32.241. You take these, this is negative, I guess. Okay, so you take these and you subtract them. 241 minus 0.459. And you get 31.782 centimeters. So that would be your first increment at 100 centimeters.
And do you keep going down like that?
So finding the slope for finding the increment, the diameter of the increment would be using the two slopes, f of x and g of x. And to find the diameter, you have to use g of x minus f of x. So this equation is the equation for the slope of f of x.
Good.
And and this equation is the equation for the slope of g of x.
Okay.
Okay, so when we do find what the answer to these are, depending on what distance we put in for x, we subtract them out to find the diameter because we're trying to find the distance between the points of the cone. So we're trying to find the distance from here to here on the cone.
Okay. That's tough.
For the equation g of x, we add in the 32. We add 32.7 because
it's the diameter of the sun and the highest point of the graph.
how much I paid AJ? Because it is the diameter of the sun and the highest point of the graph.
Hold on. All right.
Distance
3. Oh, negative.
of
Sun
equals
negative 3.
What I'd like for you to do,
equals 1.
does she just want you to write the answers over there?
I don't know, but that's in pen, so
What?
I don't know.
It's in pen?
All right.
Yeah.
So the sun, diameter of the sun, diameter of the earth, length of the hallway. These four numbers are going to help us create the scale. Okay, to find the scale, take the diameter of the earth and the distance between and the diameter of the earth equals equals 11,759. And we did test and check. The numbers gradually gotten smaller. We took this number and we tried to compare it to the hallway length, which is 3,527.7 centimeters.
Explain that 11,759 is the distance between.
Okay. Alright. So we multiplied 1 by 11,759, which is the distance between ratio, in the ratio. And we got 11,759.
Now you use that ratio to see what we fit the hallway.
Right. So we took this ratio to see if it would be able to fit this hallway. It didn't. So we started going, okay, we need to go smaller. So we did 0.5. We kept half, well, yeah,
Half the first one.
we sort of just went down the row. By the distance between, which is 11,759, and we got 5,879.5 centimeters. That didn't fit as it either. So we took the 0.3 and multiplied it by the distance between and got
Explain that 0.4 was too big and 0.2.
okay. And we got 3,527.7 centimeters. We were happy. It fit perfectly. we realized 2 would be way too small. We'd have too much space on each side, and point 4, again, was way too big.
Alright, the length of the hallway is 39.19 meters. There's a little slack. There's a little slack in between here, which is about 100 centimeters, and down there it's about 300 centimeters. Together they add up to equal 400 centimeters of slack. The middle crease here, if you can see it, is the radius from the top of the ceiling to there. We measured 37 from the ceiling to the middle line all the way down so that the paper doesn't taper. It looks like it's going up, but it's really not. It's actually really even. It's just getting smaller as it goes down the hallway. It's parallel with the ceiling. So, it's 3,527.7 centimeters down the hallway.
I just want to document that the elves left coffee for me today. I don't know where it came from, but I thank them very much.